So the relative velocity of an object compared to an observer. This will change depending on the motion of the observer. That's why Paul Walker won. Brian Walker? Brian O'Connor, yeah. The main guy. Okay.
You can't let the main character lose.
No, that is true, yes. It does not work that way. Alright, so we're going to create a rule very, very similar to the displacement rule. Of P as observed or relative to Q is P relative to Q. That's the velocity of P. Take the velocity of Q. So say you're going the same direction, right? This would be the object's true velocity. So say you're going at 130 kilometers per hour in north. This would be the observer's velocity. So going back to what Matt said, you have to add them. Why in the video did we have to add them? Well, you're going negative of each other, so it's actually 120 take negative 140 because they're going opposites of each other. So if that's positive, that's going to be negative. So that's why you added them in that video. That's why it's quite scary sometimes. And that's why the most dangerous crashes are head-on collisions. Let's do an example 1. I'm on ship A, which is sailing due east at 15 kilometers per hour. Another ship, let's call it ship B. There are also a few ships in Perth, in Fremantle docks. They're not allowed off. Actually, they're going to Rottnest, I think, to be quarantined because they might have the virus. Yes, if they're not. Yes, that's correct. So hopefully they don't spread. Anyway, so another ship called Ship B sails close by a speed at 21 kilometers on a bearing of 210. What is the velocity of Ship B relative to Ship A? So you are on Ship A. What is Ship B's velocity when you're looking at it? Alright. First of all, we'll start with a diagram. Let's start with, you're there, you're going east. So do a little diagram. Hold on, let's draw the rule first. So we need B A, right? I need ships B relative to ship A, ship B relative to ship A. So this would be the velocity of B take the velocity of A. So sailing due east, is that from east or is that to east? That's to east. Well, what does it say? We want negative A. So we should actually have negative v of a. Now I'm going to change the direction, and I'm actually going to go that way. And then let's see, VB. So the ship sails B, I have to add it onto A, so it has to be added on from here. Sails close by at a speed of 21 kilometers on a bearing of 210. So the bearing of 210 should be roughly, let's see, well that's 180, that's 270, so 210 should be there somewhere. So that's VB. So we got negative VA, add VB, or VB take VA. So what I want to do is basically find this.
Just like the other stuff.
Yes, exactly the same as the other stuff, except we're dealing with velocities. But the concept is very, very similar, yes. Alright. So let's see, what is the velocity of ship speed relative to ship A? So the velocity in this case, because these are velocity vectors, is just the magnitude. So we want the magnitude of VB take VA. Let's see. Do we know our velocities? Well, I know that this is going to be 15 kilometers per hour, and that's going to be 21. Oh, there's a specific rule that I can use. It starts with a C, ends with an E. Cosine rule, yes, but there's a missing component here. I've got these two lengths. I want to find this. I need this angle though. I'm going to use some trigonometry to find that angle. Let's see. What do I know so far? I know that this angle here is what? Jordan, have a think. What would that angle be there? So I know from there to there is 210. So from 180 to 210, how many is that? 30. So this angle here is 30. And if that's 30, then what will this be? That would be 60, that's correct. So that's 60, this would be 120. All good? Good? Okay. So that's 120, we got 15, we got 21. We can use the cosine rule to get our velocity. Let's see, we got 15 squared plus 21 squared. Take 2 times 15 times 21 times cos 120. Pop that into your handy dandy calculator. You get 31.321 kilometers per hour. Check that number, make sure it's correct if you have the CAS with you.
Why did you write it bracket instead of multiplication symbol?
It's just a notation, it means the same thing.
Well, it means the same thing, but like, is there any particular reason you did it in a different way?
No, I'm just showing you that you might see it in this way, or you might see it in the other way. Exposing you to many things. As many things as possible. Alright, the bearing. What bearing am I talking about? Max, which angle do I have to find the bearing of B relative to A? Bottom left. This one?
Yeah.
Very, very close, Max. But let's see where my direction is going. My direction is going this way. So my bearing is from the beginning of the vector. So it's actually this guy here, from there to there. So let's see, how do I work out this angle here? Let's call it theta. Now, even if I did what Max did, and I worked out theta there, I just got to go 180, take that, and I find that. So either one is fine. Excuse me, what rules should I use? I can use the cosine rule or the sine rule. I'll use the sine rule. We haven't used that in a while. Sine theta over 15 equals sine 120. Oops. Sine 120 over are you serious? There we go. Over sine 120 over 31.3 dot dot dot. Solving for theta, I get 24.5. Does it varying have decimals? No, it does not. So my answer should be the velocity of wind is 31.321 kilometers per hour. Sorry, of the velocity of ship B is that speed with a bearing of 235 degrees relative to ship A. So Max, I see why you said that one, because that's where A is, right? But because the vector's going that way, you have to get the direction right as well. Alright, example 2, find VB, not fond VB. Right, so let's see, we have this, wow, this seems quite trivial, and in fact it is. Right? A relative to B is the velocity of A, take the velocity of B, therefore VB is velocity of A, take a velocity of B. Let's pop that into let's pop our numbers in. 3, -5, plus, sorry, 3, -5, take 5, 7. 5i plus 7j. And we have -2 to 12. So the apparent wind, or the apparent velocity of B is -2i minus 12j. Questions on example 2, pretty straightforward, I think. Alright, a yacht with a velocity of 15i and 2j, and the wind appears from the yacht to have a velocity of -i plus 2j. Be very careful. So I'm trying to find the true velocity of the wind. So if you go back up here, that's the true velocity, that's the observer's velocity. So we're observing the wind, and let's just call that y for yacht, and let's call that for wind. Going back down here, we have w, v, y. Oh, sorry. Okay. Let's see. Let's expand that into the velocity of the wind. take the velocity of the yacht. Hi, Ryan. Alright, so we want to find the velocity of the wind. So we're just going to rearrange this equation here to velocity of y plus that. So just some very simple rearranging. So which one of these do we put into my formula? Jenny, what is the velocity of the wind relative to us? Which one is it? Is it that one or that one?
The negative 902J.
That's correct. Boys, you should be paying attention. That's correct. And then the velocity of the yacht, which is already there, is 15I plus 2J. Added together, nice and easy, plus 4J. So in other words, the true velocity of the wind is 6I plus 4J. So very, very similar to displacement, but a little bit different. Any questions on the notes? Okay.